In the previous video, I have explained about charge carriers. So in the case of conductors, it is free electrons. Now in this chapter, we are only going to learn about electricity or movement of charges through conductors. So it is basically free electrons in as charge carriers. Okay. Now, we have learned that when we are not connecting any potential, when we are not providing any electric field, there are still the movement of electrons. Which are these electrons? Free electrons. Now these are thermally generated electrons, right? Free electrons. Thermally generated means at 300 Kelvin, at room temperature 27 degrees Celsius, there are a lot of electrons which are free from an atom, or these are free electrons. They can contribute towards conduction. Now these electrons, see, it has now energy, right? Because it is thermally excited. Now these electrons will be in zigzag motion. They will move in random directions. Zigzag means in all the direction they will be moving. So what do I mean? There are movement of charges when we are not providing any electric field or any potential. But why we are not able to measure a current here in this case if there are movement of charges? See, check what is the net movement of charges. Now, as there are a lot of electrons here, whenever an electron is moving in this direction, there is a chance that some other electron is moving in this direction, making the effect cancelling. Okay. Similarly, when some electrons are moving in this direction, there is a possibility that somewhere there is an electron which is moving in this direction, so that the net effect is cancelled. So that when we are summing up all the current, then finally the net current will be zero, because they are moving in random directions. Now, another important thing, now when they are moving at high velocity, let me give you the value of velocity, that is 10,000 meters per second or 10 kilometers per second. They are moving at high velocity. Now why can't an electron come out? Let's say when these are moving in this direction with such a high velocity, why can't an electron go out of the conductor? Now when an electron goes out of the conductor, what is the charge of an electron? Negative, right? Now basically when all the electrons are there inside the conductor, we know there are equal to the number of electrons, we have the same number of protons. So number of electrons and number of protons are same. For example, we have how many electrons here? 1, 2, 3, 4, 5, 6 electrons are there. For the moment I am going to take, there are 4 positive charges, 4 protons. Now as of now, when the electrons are not escaping, when the electrons are not moving out, number of electrons are, this is 6. Number of electrons are 6 and number of protons are 6. So the net charge is 6 minus and 6 positive, net charge is 0. Let's say when an electron is coming out, when an electron is going out, the total number of electrons here in this case will be 5. So 1 electron is outside. We have 6 positive charges here. So what will be the net charges on the conductor here? 6 positive and 5 negative charges. So here in this case, 6 positive and 5 negative charges, the net charge will be 1 positive. When the net charge is 1 positive, we have an electron outside. These positive charges will bring the electron back. That will attract this electron back. So basically, this electron cannot escape out. The moment an electron goes out, the electron is negative in charge and the total conductor will become positively charged, and this positive charge conductor will take the electron back so that this electron cannot escape. Now, I have explained you these are electrons which are thermally generated, or these are free electrons, and these free electrons have a velocity that is nothing but thermal velocity. But these free electrons or movement of electrons with thermal velocity doesn't contribute towards conduction because they are in random motion. The net effect is cancelled. Now next concept is drift velocity. I'll explain it in the next video. Thank you.